Let's go through Liquid 1593 split the array into the max number of unique substrings. It gives us a string S. Return the max number of unique substrings that given string can be split into. And the substring cannot be empty string. And you see that the substrings must be unique. That means if, for example, we split um, the example one, right? I can split as A, B, A, B, C, C, C. And none of these substring appears twice. And this one is not valid because A appear and B appears multiple times. So what we're thinking about is that we trying to search those kind of split positions. So that is our DFS, right? So we use a set to dedupe. And when for this kind of DFS, we need an index. When the index equals the string dot length, and that will be the exit condition. And before exit, we should compare uh, the set size, right? So after we split, um, we trying to see what is we split a string. We put that string uh, into the set, and we compare those kind of set size with the global max value. And we search the split position. So we need an index as a DFS parameter, and we need a string as a DFS parameter. We need an set, right? Set to dedupe as a DFS parameter. We can also pass the result as a reference, right? Or use the global, whatever you want. So then I think we can just write code for this. We can use the int result. I like to use this one to pass as a reference, and new int one and DFS. So we need a string s. We need a new hash set to dedupe. After we split, we put those kind of split string into this kind of subset, this set, right? And also we use this set to trim our DFS branches. If for some kind of the split, the set already contains the string, then we're going to continue, right? We cannot split that so that our branch can be trimmed, and the index, right, and the result. In the end, we just return result 0. So what we need is the private void DFS, and we can have string is and set string set, right, and int index and the result. So what we do is that if let's have int n equals s of length. If index equals n, we should return. Before return, we have result 0 equals max dot max result 0 and the set dot size. Then what we do is that for int I equals, we just enumerate those kind of split places, right? And I smaller than n, I pass. So we'll say if we'll get the string, this string str equals s dot substring index I plus 1, okay? Because you can also use I equals index plus 1 smaller equal to n, right? Or depend on how you, but you just make sure right? It's not empty. So if set contains str, we just need to continue. And we need to have if it doesn't contain the str, we added this str, right? And then DFS, right? And backtrack set remove str. DFS to the next layer that is set, right? So I plus one result. So this will be the code. It will be for if the string has length n, right? For every position, we have choose to split or not split. So the time complexity will be 2 to the power n, and space is linear. We have an set, right? Um, the Python code is very similar. And we still use this result equals result still, right? And DFS is set and the index 0 result return result 0, and we define DFS. So um, we need a if we don't have this set, it should be fine, right? And if we don't have this set, we don't need this parameter. Um, can have a scene as set and the index as int result as list return none, right? So this is then what we do is that n equals length. This one can also put outside, right? We don't need to do every time. Length s. So that means that um, if index equals n, we just need to result 0 equals next result 0 and stat length, right? C. Um, length of C return. And what do we do is that for I in range index to n, then substring equals is s from index to I plus one. And if substring in scene, we need to continue. Then we just have scene add substring and scene remove scene remove substring. And before this, we need just a DFS. DFS scene I plus one and result.